I want to take you to a very specific moment. It's usually late, maybe 9:00 p.m.
Oh, I know this moment.
You have friends over, or maybe it's just a Tuesday and you need a win. You've got a bowl of that expensive dark chocolate, you've got a pot of heavy cream, and you are going to make ganache, that glossy mirror-like chocolate sauce you see everywhere.
You think it's going to be simple?
You pour the cream, you start to stir, and you are expecting like magic.
And instead,
Okay.
you get a crime scene.
Exactly. It's a tragedy. 1 minute it looks perfect, and the next it snaps. The shine is gone. It's all grainy and dull. And then the ultimate betrayal. A pool of clear, greasy oil separates out. It just sits on top of this sludge. It's ugly, it's unappetizing, and it feels like you just burned $20.
That is the dreaded breaking. It is the culinary equivalent of a breakup. It comes out of nowhere, it's messy, and you're left just wondering, what did I do wrong?
And you usually assume it's bad luck, right? Or, I don't know, maybe the chocolate was old. But the sources we've pulled for this deep dive argue that luck has absolutely nothing to do with it. This isn't a curse, it's a physics problem.
Exactly. If you look at it on a molecular level, a broken sauce is just, that's a misunderstood equation. So today we're doing a deep dive into the science of ganache. We're going to unpack the accidental history of this stuff, which is, well, it's actually hilarious.
Right.
And then we're going to get into the hard chemistry of emulsions. Why fat and water basically hate each other and how we can force them to get along.
And maybe most importantly, we have the emergency room protocols. Because apparently, even if you've created that oily mess, you can save it if you understand the fluid dynamics.
That's the key. Pastry chefs aren't magicians. They're just, they're engineers.
Yeah.
Once you know why that molecular bond breaks, you can almost always snap it back together.
Okay, so let's start with the name itself. Because before I read through all this research, I just assumed ganache was fancy French for exquisite chocolate cream. It just sounds so sophisticated.
It does sound elegant, doesn't it? You see it on a menu and you think of some high-end patisserie in Paris.
Yeah.
But the origin story is, it's a total comedy of errors. It literally starts with a kitchen nightmare.
Okay, set the scene for us.
So we're in a professional kitchen in Paris, late 19th century. And you have to imagine the atmosphere of a French brigade kitchen. It's militant. It's incredibly high stress, the master chef is God, and everyone else is just trying not to get fired.
So high stakes, hot ovens, lots of angry chefs. Got it.
Exactly. And in the middle of all this, you have a young, terrified apprentice. He's carrying a pot of boiling hot cream. And he trips, or his hand slips, and he just dumps the entire pot of boiling cream into a bowl of very expensive chocolate.
Which I'm guessing was not on the recipe card.
Not even close. In that era, that was a catastrophic waste of ingredients. The master chef sees this, and he loses it. He starts screaming at this poor kid. And the specific insult he hurls at him is ganache.
Wait. He called the boy a ganache.
He did. In the slang of that time, ganache didn't mean chocolate. It meant fool. It meant imbecile or idiot. One of our sources says the literal translation is sursem, which means someone who's just dopey or totally incompetent.
That is fantastic. So every time we order a chocolate ganache cake, we are literally ordering a chocolate idiot cake.
Essentially, yes. You are eating the moron's mistake.
Yeah.
But here's the twist in the story. After the chef finished screaming, he looks down at the bowl. He probably grabs a spoon, to see if anything can be salvaged from this mess.
Right.
He stirs it, probably quite angrily. And he realizes something very strange.
It wasn't ruined.
It wasn't ruined at all. The boiling cream had melted the chocolate, and the agitation from his angry stirring created this unbelievably smooth, velvety emulsion. It was actually better than whatever they were originally trying to make.
So the insult just stuck to the sauce.
The name stuck. They kept calling it ganache, probably as a joke at first, but then it became the standard term. It started as a filling for truffles, but because the texture was so versatile, it just took over the pastry world. Glazes, fillings, frostings. It's like the duct tape of the patisserie.
That's a great reminder that some of the best inventions come from total incompetence. But let's pivot to the science, because while the first ganache was an accident, repeating it requires intention. And this is where it gets tricky.
Right, because if you just look at the ingredient list, ganache shouldn't even exist.
But it's just two things, chocolate and cream. How complex can that possibly be?
Oh, it's chemically hostile territory. Think about what those ingredients actually are. In the chocolate, you've got cocoa butter, which is fat. You have cocoa solids, which are fibrous particles, and you have sugar.
Okay.
And in the cream, you have mostly water with some butterfat mixed in.
And as we all learned in, Third-grade science, oil and water are mortal enemies.
They are polar opposites, quite literally. Water molecules are polar, fat molecules are nonpolar. They want to stay as far away from each other as possible. So when you make ganache, you are forcing what our source calls a fragile piece. You're creating an emulsion.
And what is an emulsion actually doing in this context?
You're suspending millions and millions of tiny droplets of fat inside the water phase, or sometimes the other way around. You have to get them so small and so well dispersed that they stop trying to clump back together. You're essentially asking them to hold hands against their will.
And because they're doing it against their will, the source material says they're looking for any excuse to break up.
Any excuse at all. It's a hostage situation. And the sources identify what they call a gang of 3 culprits that usually cause the whole thing to go bad.
The gang of 3. I like that. So these are the 3 reasons my ganache breaks.
Yes. Heat, ratio, and impatience. If you have a grainy, oily mess in your bowl, it is guaranteed to be one of these 3 things.
Okay, let's break them down. Let's start with heat. Because looking back at that apprentice story, he spilled boiling cream. So I've always just assumed boiling is fine. But the experts say otherwise.
The apprentice definitely got lucky.
Yeah.
But generally, boiling is what we call the temperature trap. If you take your cream to a full, aggressive, rolling boil and dump it on chocolate, you are asking for disaster.
Why? I mean, what does that intense heat actually do to the chocolate?
The source uses a very vivid and slightly gross phrase for this. It says, if the cream is too hot, the chocolate vomits oil.
That is a distinctive image.
But it's accurate. Think about the cocoa butter inside the chocolate. It's held in a very specific crystal structure. If you hit it with a 100 degrees Celsius liquid, you shock it. You break the protein structure in the milk solids that normally helps hold the fat in place.
Right.
It's like squeezing a wet sponge. The structure seizes up and just squeezes all the fat out to the surface.
So that's the oil slick. It's the cocoa butter literally trying to escape the heat.
Precisely. You've broken the emulsion before it even had a chance to form.
So what's the sweet spot then? If we aren't boiling it, how do we get it hot enough to melt everything properly?
You want a gentle simmer. A good visual cue from the chefs is to look for tiny bubbles just forming around the rim of the pot. You don't want a mosh pit of a rolling boil. You want a polite conversation. In terms of numbers, that's about 80 to 85 degrees Celsius.
Okay, polite bubbles. I can remember that. Culprit number 2 is ratio. And this feels like where people like me who, tend to eyeball ingredients. This is where we get into trouble.
Eyeballing is the mortal enemy of an emulsion. The ratio is the balance of power. If you have too much chocolate, there just isn't enough water in the cream to hydrate all the solids. The whole thing gets dry and clumpy, almost chalky.
And if you have too much cream, the opposite problem.
Exactly. Then the fat droplets are just swimming in this huge ocean of water. They can't find each other to create that semi-solid structure. You just get chocolate soup. It'll never set.
Okay, we'll get into the specific golden ratios in a minute, but I want to talk about the third culprit. This is the one that really hit home for me. Impatience. Or, as the source calls it, the agitation error.
This is maybe the most common mistake for home cooks. You pour the hot cream in, and your first instinct is to whip it into submission. You grab a whisk and you just go crazy.
Well, yeah. I'm trying to mix it. I want it to be smooth.
But you're being a bully. The source says, and I love this phrase, ganache is persuaded, not forced. When you use a whisk aggressively, a couple of bad things happen. First, you're incorporating a ton of air.
Which we don't want.
We definitely do not want air. Air bubbles refract light, which completely kills the shine. It makes the ganache look dull and matte. But even worse, by beating it like that, you are mechanically separating the fat before it has a chance to emulsify. You're just stressing the ingredients out.
So if the whisk is out, what's the proper tool?
A simple silicone spatula. And the technique, the movement is very specific. You don't just stir the whole bowl at once. You start in the dead center. Small, tight circles. You're creating what the chefs call a friction core.
A friction core?
Yeah, you're mixing just a tiny bit of cream and chocolate right in the middle until it turns glossy and dark. Once that core is stable, then you slowly widen your circles to bring in more of the liquid from the edges. You let the emulsion grow outward from the center.
That sounds almost meditative, like a Zen garden, but with calories.
It really is. And if you rush that circle, you can break the bond. You have to wait for the chocolate to accept the cream.
Okay, so we're being gentle, we're watching the heat. But let's go back to the math for a second. Because you said ganache is super versatile, truffles, glazes, frosting. How do we control what we actually end up with?
It is all in the ratio. The real beauty of ganache is that it's predictable. If you weigh your ingredients, you control the final texture. It's that simple.
So walk us through the big three ratios.
Okay, so the classic is 1-to-1, equal parts chocolate and cream by weight. This is your Swiss Army knife ganache. It's soft enough to pipe, but it's firm enough to hold its shape. This is what you'd use for a classic truffle filling.
Got it. What if I want something more structural, like a stiff frosting or a coating that snaps when you bite it?
Then you need more solids. So you go 2-to-1, 2 parts chocolate, 1 part cream. This is going to be dense. It sets up hard.
And the reverse. What about that pourable sauce for, say, an ice cream sundae?
That's 1-to-2, 1 part chocolate to 2 parts cream. It's a very loose emulsion. It stays liquid and pourable even when it cools down to room temperature.
Now, there's a nuance here in the notes that trip me up. This all assumes we're using dark chocolate, right?
Yes, and that's a critical distinction. White chocolate and milk chocolate are completely different beasts chemically.
Is that because they have less cocoa solids?
Well, white chocolate has 0 cocoa solids. It's just cocoa butter, sugar, and milk powder. And because it's missing those fiber solids, it's naturally much softer and more unstable. If you try to use a 1-to-1 ratio with white chocolate, you're going to get soup.
So what's the adjustment you have to make?
You have to starve it of liquid. You reduce the cream, sometimes significantly. White chocolate needs a lot less moisture to hold an emulsion compared to dark chocolate. So you really have to tweak the math based on the cocoa percentage of your bar.
That explains so many of my failed holiday desserts. I was treating all chocolate as equals, and the physics, it just didn't agree.
The physics never compromises.
All right, let's get to the part of the show where we save the day. Let's say I ignored all of your advice. I boiled the cream, I whisked it like a maniac, and now I have a bowl of grainy sludge with an oil slick on top. Is it trash?
Never. Do not throw it away. A broken ganache is just an emulsion that is separated. The ingredients are all still there. They just need to be reintroduced properly.
So how do we play matchmaker again? What's the first step?
Method 1 is the gentle fix. This works if the break is pretty minor. Maybe it's just a little oily around the edges. You take 1 teaspoon of warm cream, not hot, just warm, and you stir it very gently into the broken mix.
Wait, you add more cream? That feels completely counterintuitive. If it's oily, doesn't that mean it has too much fat already?
It seems wrong, I know, but remember, cream is mostly water. By adding that little bit of extra liquid, you're giving the fat droplets more space to disperse. You're relieving the overcrowding in a way. And often, just that tiny bit of extra hydration is enough to allow the emulsion to snap right back together.
Okay, but what if it's a total disaster? I mean, what if it looks like cottage cheese swimming in motor oil?
Then we stop being gentle. We go to what the pros call the nuclear option. You need an immersion blender.
Hold on, we just spent 5 minutes talking about how violence ruins ganache. You said persuade, don't force. An immersion blender is a buzzsaw in a bowl.
It is violent, yes, but it's a very different kind of violence.
Yeah.
And this is a really important distinction in physics. When you whisk by hand, you are beating the mixture. You're splashing it around, trapping air. That's bad. An immersion blender provides shear force.
Sheer force. Okay, explain that like I'm 5.
Imagine the blades spinning at thousands of RPM. They create a powerful vortex. They suck the big, clumping fat globules down into the blades, and they literally slice them, they shear them into microscopic particles.
So you're basically atomizing the fat.
Exactly. You are forcing the fat droplets to become so incredibly small that they have no choice but to stay suspended in the water. They become too small and too numerous to separate out. It's not magic, it's just brute force fluid dynamics.
That is incredibly satisfying to visualize. You're just obliterating the problem on a molecular level.
It works in about 15 seconds. You'll literally see the sludge turn into a mirror right before your eyes. But, and this is a massive but, there is one rule you absolutely cannot break.
The warning label.
The submersion rule. You have to keep the head of the blender completely submerged below the surface of the chocolate at all times. If you lift it up even for a second and you hear that slurping sound,
Game over.
you've just injected millions of tiny air bubbles into your ganache. It'll turn into a light, foamy mousse. You'll lose that dark color, you'll lose the shine, and you can't undo it. You want the shear, not the air.
So tip the bowl, bury the blender, and do not let it breathe.
That's the rule.
Okay, there was one final Hail Mary fix mentioned in the sources, adding something like glucose or warm milk.
Yeah, that's the last resort if you're completely out of cream. A little bit of warm milk or liquid glucose can help rebind the emulsion, but the source warns it might change the final flavor profile a bit. Stick to the blender if you can.
All right, we've covered the disaster scenarios. Now I want to walk through the perfect protocol. The source gave us a step-by-step for a flawless start, so we don't even need the blender in the first place.
Right. Let's use the standard dark chocolate recipe. 200 grams of chocolate, 200 milliliters of cream. Chop your chocolate up pretty small, place it in a bowl, and ideally a glass bowl, not a metal one.
Why not metal? I love my stainless steel bowls.
Metal conducts heat way too fast. When you pour the hot cream in, you want that heat to stay in the bowl to melt the chocolate. A metal bowl just radiates the heat away into the air too quickly, and you risk your chocolate not melting all the way through. Glass is a much better insulator.
Okay, glass bowl. Step 2, the cream.
Heat it gently. Look for those tiny bubbles around the edge. Do not boil it.
Step 3, the pour.
Pour the hot cream all over the chocolate. Make sure all the pieces are submerged.
And now, step 4. This is the one I struggle with. The recipe just says, do nothing.
The pause. You wait exactly 30 seconds. Hands off the bowl.
I have to be honest, when I'm making dessert, I am not a patient person. I want to start mixing immediately. Why are we waiting? Is this just some chef superstition?
No, it's pure thermodynamics. Chocolate is actually a decent insulator. It takes time for the heat from the cream to really penetrate to the center of those chocolate chunks.
So if I stir right away, what happens?
You're just cooling down the cream by moving it around while the center of the chocolate is still hard and cold.
Yeah.
You'll end up with these little unmelted lumps that will never, ever go away. The pause allows the temperature to equalize. It softens everything up so it's ready to bond.
Okay, 30 seconds of silence. Then what?
Then, the friction core. Spatula in the center, small circles. Watch that darkness form. Slowly move outward. And stop the second it's all combined. The chefs have a saying, more is harm.
More is harm. I think I need to tattoo that on my forearm.
It's so true for pastry. Once it's shiny and unified, stop touching it. And actually, there's one final tip that most home cooks always skip. Let it rest.
Rest. It's not a steak.
No. But the cocoa butter inside it needs time to set up and crystallize properly. If you use ganache the second you mix it, it's still a little unstable. But if you let it sit at room temperature for an hour, the texture completely transforms. It becomes spreadable velvet. It reaches its final perfect form.
You know, listening to all this, the listening for the bubbles, the persuading, not forcing, the letting it rest, it really changes how I view the whole process.
And that's the core philosophy of the source material. It explicitly says, chocolate is not just an ingredient, it is a character.
A character with a temperament?
Exactly. If your ganache breaks, it was not random. It's speaking to you. It's saying you rushed me or you burned me. It's a relationship.
That is actually a really profound way to look at cooking. We tend to think of recipes as just, commands do this, then do that. But this deep dive really suggests that cooking it's a conversation.
It is. You have to listen to the physics. You have to watch for the reactions. You can't just try to dominate your ingredients.
And if you stop trying to force it and you start to understand the rules of the emulsion,
the food answers back. And in this case, the answer is silky, perfect chocolate.
I think I'm ready to go apologize to my chocolate chips. Thanks for listening to this deep dive. Go forth and emulsify.
See you next time.